All right, welcome back to day 3 of the notes for 7.1 Matrices and Systems of Equations. So with that said, we will jump right in here. Okay, notice here we have an augmented matrix, and what they're going to ask us to do here is to write this system as a system of equations and then use back substitution to solve. So we're going to start with the augmented matrix, change it to linear equations. So in this case, x minus 2y equals 4 and y equals negative 3. That worked out really well because we already have y, and so now I can plug negative 3 into this top one for y right there, and that will allow me to solve for x, which is negative 2. So for this first equation, two equations, two variables, this one was already solved for y, so that was nice. We end up with negative 2, negative 3. So again, from the augmented matrix, write your equations. This one was already solved, so I can substitute that back into the top, and then I can find x. And don't forget to write your answer as an ordered pair. Okay, next example is going to be very similar, only this time we have 3 equations and 3 variables, kind of like we did at the end of Unit 6. Again, this is going to work out really nice for us. So notice we're going to get x, y, and z, and then what they equal. Notice this bottom one, there's no x and y, so we just have one z equal to 8. So that works out really well. So there's our equation. And now that we know what z equals, we can plug it back in here, since we know that 1y plus 3z equals 29. So that's our next equation. Substitute 8 in for z. And so we have y plus 24 equal to 29. Subtract 24, and we know that y is 5. That now sets us up to do the third and final equation. So we have 1x minus 3y plus 2z equal to 10. We know y is 5, and we know z is 8. So we can substitute those values in, and that will allow us to solve for our last value. And so we'll multiply, and negative 5 plus 16, that'll give us 1, so x plus 1 equal to 10. Move that 1 over, and so when I move that 1 over, now I get x equal to 9, and now I have my 3 numbers, 9, 5, and 8. So in this case, since it's a system of 3 equations and 3 variables, we will write our final answer as an ordered triple. Again, the nice thing here, you're starting with an augmented matrix. You can get back to your equations and in turn solve. And for those first 2, they were nice. In this one, they gave us z equals 8, and in the previous one, they had already solved it for y. Okay, similar idea here. This time they did not solve for x or y for us, but we know how to do this. We can do this a couple of different ways. You can change it back to the equations, but I wouldn't mess with that. It's going to be a similar idea. So change it to the augmented matrix like we did, and then we're just going to go row echelon form. And so what we'll do here, notice I've got a 1 here, so I want to make this a 0. I will multiply this by negative 2 and add it to the bottom row. And so when I do that, I will get negative 2 times 1 is negative 2. Negative 2 plus 2 is going to be 0. Negative 2 times 2 is negative 4, plus 1 is negative 3. Negative 2 times 7 is negative 14, plus 8 is negative 6. Ideally, I want this to be a 1, so I'll just go ahead and multiply this entire row now by negative 1/3. So negative 1/3 times 0 is still 0, times negative 3 is 1, and times negative 6 is 2. And now that I've solved or got this augmented matrix down to row echelon form, now I'm in business because I know y equals 2, and then I can plug that back into the top equation, which we know was x plus 2y equals 7. And so we'll plug that in to the x plus 2y equals 7. We know again y was 2, so we plug it in right there. And then we will move our 4 over. I probably should have put that one in there. X plus 4 equals 7. That makes it a little easier to see. My apologies on that. So again, move the 4 over and x is 3. So again, we knew from up here y is 2. Plugged in the other equation, x is 3. Write our ordered pair. All right, here's an example where they give us two matrices and they want to know is it in row echelon form, and if no, we need to get it there. This first one is indeed in row echelon form, and in fact it's really in reduced row echelon form. If you remember from a couple of days ago, if you have a row of zeros, it has to be in the bottom, and you'll notice in this matrix it is. We have our leading ones in each row. They are staggered, so this one's further to the right than that one, so we're okay there. And in each row that has a leading one, all the other, or each column, excuse me, all the other entries are zeros. So this is in row echelon form, and in fact it's in reduced row echelon form. All right, the second one you can see right away, this is not a 1 here, so we are out of luck, so that's a no, but we want to get it there. If I multiply everything in this row by 1/2, that will give me 1, 0, 2, and 0. And then my only problem right here is this -1, so I'm going to multiply everything in here by -1, and then I get this result here. So multiplying the top row by 1/2, I get 1, 0, 2, 0. Multiplying the middle row by -1 will get me here. And my bottom row, we were already good, and this is now in row echelon form. All right, one final slide today, and then we'll be wrapped up here. Okay, so again, we've got a matrix here, and we're going to try to get this into row echelon form. Notice my first row is good here. We're starting with a 1. That's exactly what we want, is a 1 in the upper left-hand corner. What I'd like to see is a 0 here and a 0 here. So we're going to tackle that first. I am going to multiply this top row by 2 and add it to the middle row so that I get a 0 right there. I'm also going to multiply this row by -3 and add it to the bottom row so I get a 0 right there. So that's the step. That's what this means. 2 times row 1 plus R2 and -3 times row 1 plus R3. Whole idea is to get these to be zeros. And so you'll see when we do that, this is my end result. So 2 times 1 minus 2 is 0. 2 times 1 minus 1 is 1. 2 times 0 plus 2 is 4. That one is a mistake there. I got to go back to that one. Or no, excuse me. 2 times 0 plus 2 is 2. Sorry. And then 2 times 5 minus 10 is 0. So there is our middle row. And then the bottom one, we multiply the top by -3. -3 times 1. So -3 plus 3 is 0. Multiply this by -3. So -3 plus 6 is 3. -3 times 0 is 0. 0 plus 7. -3 times 5 is -15. Plus 14 is -1. So again, we're almost there. So there's a couple different ways we can go about this, but for this row, we'll do right here now. So we'll take this middle row times -3 and add it here again. That'll give me a 0 there. And that worked out well for us. -3 times 1 is -3, plus 3 is 0. -3 times 2, -6 plus 7 gave me a 1, which is fantastic. And then -3 times 0 is -1. And we are in row echelon form. Now, if I got a number other than 1 here, say I got an 8, then I would just multiply this row by 1/8, and it would be done, because that would give me a 1 here. So it worked out well for this one. The multiplication and adding the 7 actually gave us a 1, so we didn't have any more steps. But if this wasn't a 1, then just multiply it by a fraction so that you can get 1 there. All right, so that wraps up our notes for day 3 of 7-1, and we're all set. All right, thanks.